We are discussing some problems of exercise 22F of probability. Okay, question number 2. The probability that a horse A will win the race is 1 upon 5. So P of A is equal to 1 upon 5. The probability of horse B will win the race is 1 by 4. So P of B is equal to 1 by 4. What is the probability that one of the horse will win? Okay, one of the horse will win, meaning is at least one will win. Okay, now at least is union. Okay, so that is equal to P of A plus P of V minus P of A intersection B. So P of A is equal to 1 by 5. P of E is equal to 1 by 4. Now P of A intersection B will be 0 because uh, at the same point of time, how both the horse will win, and it's given the same race. Okay, so these are mutually exclusive events. So you can solve this and get the answer of 1 by 5 plus 1 by 4. Okay, question number 4. There is a group of 2 men and 3 women. So men 2, women 3. The total is 5. Okay, 3 persons are selected at random from the group. So n of s is equal to 5c3. 3 out of 5 are selected. Okay, what is about that? One man and two women, or two men and one woman is selected. So case 1, so one man and two women. And case 2, two men and one woman. So one man out of two can be selected in 2C1 ways, and two women out of two women out of three can be selected in 3C2 ways. Okay, two men from two men can be selected in 2C2 ways, and one woman one woman from three women can be selected in 3C1 ways, and is multiplication. Okay, so you can calculate the answers for the individual cases. Okay, whatever is the answer, and you can add because in between cases there is always or. Okay, so the total of this will be, let's say, n of a. So P of a is equal to n of a upon n of s. In a class of 25 students with roll number, that problem basically you people can try on your own. Let us go to question number 6. The chance of A winning the race will be is 1 by 6. B winning the same race is 1 by 3. What is the chance that neither will win? Okay, so neither wins means A is not winning and B is also not winning. A not winning is A dash, B not winning is A dash. I'm saying and because neither indicates neither nor. Okay, so by De Morgan's law, I can take this complement outside. So intersection changes to union. Okay, and P of A union B complement is 1 minus P of A union B. So that is equal to P of A plus P of B minus P of A intersection B. So 1 minus A intersection B will be 0 because in the same race how both can win. Okay, so mutually exclusive events. So this is 1 by 6 plus 1 by 3. You can calculate this further and get the answer. Fine. That was question number 6. Let me find out some more problems. Question number 9. Sub question 1. Two events have probabilities which is given to us. So P of A is equal to 0.25, P of B is equal to 0.5. Okay. The probability that A and B will occur simultaneously. There is intersection between the two. These are not exclusive events. Okay. So they are asking neither A nor B occurs. So P of neither A nor is and. Okay. P of A union B complement. I'm taking complement common, intersection changes to union. This is De Morgan's law from set theory. P of A union B complement is 1 minus P of A union B, which is 1 minus P of A plus P of B minus P of A intersection B. We have all the three values. We can put all the three values and get the required answer. Okay. Sub question 2. P of A is equal to 0.5. P of B is equal to 0.3. A and B are exclusive events, so P of A intersection B is equal to 0. Neither A nor is and B is occurring, is A dash intersection B dash. Take complement common, intersection changes to union. De Morgan's law. This is 1 minus P of A union B. 1 minus box bracket P of A plus P of B minus P of A intersection B. All these three values we have. This obviously is 0 because A and B are exclusive, right? Yeah. Let us go to question number 10. Sub question 1. A box contains 25 tickets numbered from 1 to 25. Two tickets are drawn at random. So N of S is equal to 25C2. Okay. What is the probability that the product of the numbers is even? Okay. Now see, when do we get the product of two numbers even? First of all, there are 25 tickets. So there are 12 even numbers from 1 to 25 and 13 odd numbers. Okay. So when do we get the product as even? Case 1, both are even. Case 2, one even and one odd. Now even and odd and even means the same thing because these tickets are drawn together at random. Had it been one after the other, even and odd will be different from odd and even. The order is important when it is one after the other. But then we are pulling the two tickets at random, so it will be the same. Even and odd and even is one and the same. So even and even, if the two numbers are even, the multiplication is even. Even one is even, one is odd, the multiplication is even. Fine. So there are only two cases, and there is always or in between the cases. So if there are two even, that needs to be pulled out from 25 tickets. So that will be in 12 C2 ways plus One even out of 12 can be done in 12C1 and one odd can be done in 13C1 ways. Okay, so this is case 1 or case 2. So n of a is the addition of both the cases and p of a is equal to n of a upon n of s. Okay, 10 sub question 2. A bag contains 7 white, 5 black and 4 red balls. White, black and red, 7, 5 and 4. So the total is 16. Okay, 4 balls are drawn without replacement. Okay, so basically without replacement that word should not be uh, put over there because it might lead to some confusion. 4 balls are drawn. Okay, there it is supposed to be at once, right? So n of s is equal to 16c4. Okay, at least 3 are black, so black and non-black. Case 1, at least 3, that means greater than or equal to 3 are black. So out of 4, if 3 are black then one will be non-black. So this can be done in, so black is 5c3 into 11c1. This is case 1. Or case 2, black will be 4 and non-black will be 0 because it is greater than or equal to 3, right? So second case will be 4 black. So 4 black out of 5 can be done in 5c4 ways into 11c0. 0 balls out of 11. So in between the cases there is always or. Add both the cases and get n of a. N of a is addition of both the cases, whatever answer you get. And p of a is equal to n of a upon n of s. Okay. So let us proceed with question number 11. So question 1. A and B are two mutually exclusive events. So P of A intersection B is equal to 0. P of A complement is 0.75. So P of A will be 1 minus P of A complement, which is 0.25. P of A union B is equal to 0.65 and P of B is equal to P. We need to find out the value of P. So P of A union B is equal to P of A minus P of B plus P of B minus P of A intersection B. So A union B is 0.65, P of A is 0.25, P of B is P, and A intersection B is 0. So from this particular equation, you can get the value of P. Okay, that is 0.65 minus 0.25. Fine. Just a second. Okay, fine. Second sub question. A and B are two mutually exclusive events. So P of A intersection B is equal to 0. P of A is 0.5. P of B dash is equal to 0.6. So P of B is equal to 1 minus P of B. 1 minus 0.6, which is 0.4. right? A or B. Or is nothing but union, and is intersection. So we use addition theorem over here. Okay, so all these three values we have, you can put the values and get the required answer over here. Okay, yeah. Question number 12, sub question 1. A, B, C are three mutually exhaustive and exclusive events. So P of A intersection B intersection C is equal to 0. See, since these are three events, so this is also 0, right? Between any two is also 0. Okay, and exhaustive events. Since it is exhaustive, P of A union B union C is equal to 1. So this data is given to us. Along with this, they have given P of B is equal to 3 by 2 P of A. Okay, and P of C is equal to half P of B. Now this entirely is given to us. Now we'll use addition theorem of three sets. P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. Now this entirely will be 0. Now A union B union C is 1 because the three sets are exhaustive. P of A. P of A basically we don't know, and that is what is supposed to be calculated. P of B is 3 by 2 P of A. This is 3 by 2 P of A, and P of C is 1 by 2 P of B. Okay, so if you add this, 2 will go over here. So twice P of A plus thrice P of A is equal to 5 by 2 P of A. 1 is equal to 5 by 2 P of A plus half into what's P of B? P of B is 3 by 2 P of A. Okay, so 5 P of A plus 5 by 2 P of A plus 3 by 4 P of A. Take LCM, 10 P of A plus 3 P of A upon 4. So that gives you 4 is equal to 13 P of A, and P of A will be equal to 4 by 13. Okay, next problem. Question number 3. Question number 12, sub question 2. So the data given is almost the same, only few changes in the data. Okay, since they are mutually exclusive, this entirely is 0, intersection is 0. Since it is exhaustive, P of A union B union C is equal to 1. Now P of A is equal to twice P of B. Therefore P of B is equal to P of A upon 2, and P of A is equal to thrice P of C. So P of C is equal to P of A by 3. Okay, now we'll write down this addition theorem once again. Okay, for three sets, the intersection everything becomes 0. So 1 is equal to P of A plus, we calculated the value of P of B. So P of B is nothing but P of A upon 2. and P of C is nothing but P of A upon 3. Now you can take P of A common, and then from this equation you can get the value of P of A. I am very sure that you will be able to do this. That was question number 12. Okay. Yeah. So question number 14. Odds in favor of horses A, B, C, D winning the race. Okay, is given to us. So odds of A winning is equal to 1 is to 3. So this is success and this is failure. So probability of A winning will be 1 upon 4. 1 upon success plus failure, right? Odds of B winning is equal to 1 is to 4. So probability of B winning is success upon success plus failure. Similarly, P of C and P of D you can definitely guess. So P of C is equal to 1 upon 6 and P of D is 1 upon 7. Find the probability that one of them wins the race. Okay, so required probability is addition of everything. At least one wins. So A will win, or B will win, or C will win, or D will win. Okay, so that is 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7. I'm not taking addition theorem of 4 different sets because that is a very big equation, because at least one indicates union, and these are all mutually exclusive events, so no need to confuse ourselves by taking a bigger equation. Okay, had it been two sets or three sets, then we could have taken addition theorem, but then this is four sets, and as it is, intersection is zero between the events or group of events, because all are mutually exclusive events. At a time only one horse will win. Okay, then let us go to question number 19 and question number 20. Question number 19. There are three events ABC, one of which must and only one can happen. The odds are 8 is to 3 against A. So odds against A is equal to 8 is to 3. So this is failure. See, it is against, right? So it is failure upon success. So P of A dash, it's against, right? So A not happening is equal to failure upon failure plus success. So P of A will naturally will be 3 upon 11, success upon failure plus success. Odds against B equal to 5 is to 2. So P of B dash is equal to failure upon failure plus success, that is 5 upon 7. Since it is against, I have written B dash, okay? And P of B will naturally will be 2 by 7. Okay. So only one event can happen at a time. So P of A union B union C is equal to P of A plus P of B plus P of C. Okay, minus P of A intersection B. See, previous problem I did not do this because there are four sets, and writing addition theorem for four sets becomes quite a task. And as it is, these are mutually exclusive events because only one can happen at a time. So this entire thing will be zero. So P of A union B union C is equal to 1 because one event has to occur. and it must occur, right? So it is exhaustive event. P of A. P of A will be 3 by 11 plus 3 by 7. Let me just check the values which we have got. 3 by 11 and 2 by 7. Okay, plus P of C. So if you calculate this, P of C will be equal to 34 by 77. Okay, so this is C happening. So C not happening will be 1 minus P of C. 1 minus P of C will be 43 by 77, right? So this time they are asking odds against. So odds against C is equal to failure upon success, or probability of failure upon probability of success. So probability of failure is 43 by 77 and probability of success is 34 by 77. So the odds against will be 43 is to 34. Okay. You can try 20th problem for self-study. Okay. It's very simple. You will get two cases. You can add those two cases. Fine. One last problem. Let us go to question number 16, sub question 2. From the same exercise, 16 sub question 2. From a well shuffled deck of 52 cards, 4 cards are drawn at random. So n of s is equal to 52 C 4. What is the probability that the cards drawn are of the same color? So case 1, all 4 red. So this will be 26 C4, or case 2, all 4 are black. So this is also 26 C4, right? So if we add these two cases, n of a is equal to case 1 or case 2, 26 C4 plus 26 C4. Okay, and P of a is equal to n of a upon n of s. Okay, so these were a few problems from exercise 22F. Thank you.